Okay, so we'll pursue discussion in pseudo calculus problems. So pseudo calculus problem in which we are pursuing the discussion and what is importance of calculus. Okay, how calculus comes into the picture when we try to solve any mathematical problem. Okay, the problem that I believe we discussed, that problem what we are taking is that what is the perpendicular line to a circular curve? What is the perpendicular line to a sinusoidal curve? Okay, these are the things that we will take. Then finally we'll try to compute the kind of rotation of a point around any axis. This algorithm is not available anywhere, though it has been implemented. But this algorithm is not available anywhere in a sense that how I can rotate a point around a line. I believe it is all right. If this is if this is if consider this is z axis and this is a point here, how I can I rotate this point around z axis? Means it will rotate like this around z axis. Okay, how I can rotate this line around x axis? It will rotate like this. Okay, how I can rotate this line along y axis? It will rotate like this. Okay, what is the other, what I want? I want is that if this is a point and this is z axis, how I can rotate around z? That is all right. Okay, can I rotate this point along any axis like this? If it is z axis, it would rotate like this. If it is along any axis like this, then it will start rotating like this. What's going on? Okay, so it will start rotating like this around a particular axis. If axis is like this, then it will start rotating like this. If axis is if axis is axis is this, then it will start rotating. Means it makes a perpendicular to the line, the plane in which it will rotate. It makes a plane, right? If this item is rotating around a particular axis, it makes a plane. The plane will cut the axis at 90 degrees. That is the concept. In that fashion, we have to find out if this point rotate around this axis theta degree. If one first point is x comma y comma z and it rotates theta degree, another point is alpha comma beta comma gamma around a particular axis. That is the question. I have a point at x comma y comma z and there is a particular axis. That axis is anything. Axis is w axis is wi w w MINJ and OK. That is the axis. MINJ and OK means this axis passes through origin and there is a point here called M, N and O. There is an arbitrary axis like this, M, N and O. There is a point at x, comma z. It rotates around a vector that is Mi plus NJ plus OK 30 degree or theta angle. When it rotates, then it comes to another point that is alpha comma beta. What is alpha comma beta? So that is the question that triggers this kind of calculus. Okay. Now the question is arising that if I have a circle, then what is the equation of a line that is perpendicular to the circle? So that is under question mark. Perpendicular to the circle means if I have a circle like this, consider I have a circle like this. This is a circle. This is a circle. Okay. If this is a circle, then this is x-axis and this is y-axis. The concept is consider this. Consider that Okay, if this is a circle and this is x-axis and this is y-axis. No, I'm sorry. This is x-axis and vertical is y-axis. Y-axis. Now, at any point here, this is origin. This is any point here, that is x. If I go up and hit here, this point is x comma y. At this point, what is the direction of this line? If I take tangent at this point, this is the direction of this point, this line. Everywhere line direction is different. At any x, go hit here, and then I get the direction of the line at this point. If I know the direction of a line at this point, direction of a line at this point, then what is the direction of a line that is perpendicular to this line? Then certainly it is like this. If here the direction of this line is like this, then line that is perpendicular to this line is like this. Here line is like this. The line that is perpendicular to this is this. Okay, this line is combination of many tangents. Here it is like this. Everywhere we have perpendicular like this. Here perpendicular like this. Here perpendicular like this. Here perpendicular like this. If all perpendicular points, if I combine together, it will make another curved line. That curved line will be considered as perpendicular to this line. Makes sense? If consider that I draw another line, consider I draw another line somewhere in the space. Here it was a circle, and then at this point, the line direction was vertical. Okay, at same point, at same, this is x-axis, same x-axis. If I move and I hit another curve, at that moment, its tangent should be horizontal. That's why it is perpendicular. So along the circle, if I take tangent, and along the new line, if I keep take tangent, and if x is same at one location, this tangent and circular tangent should be perpendicular to each other. What I'm trying to say is, if x is same, if this is x-axis, at same x it hits circle point. Their line has a direction. That is, we say the tangent at that point is the direction of the line. The direction of the line at any point x, this is circular line. There is another line, curved line. There also x would go and hit. There the line direction and circular line direction at that point should be perpendicular to each other. For every x, if I take circular line direction, every x, the circular line direction is like this. Every x, whatever the circular line direction is, same x, if I take another curve, thus the line direction would be perpendicular what direction I get for the circular line. What is equation of that line? That is under question mark. Later we will see theta degree also. Means, can I have a line that is at theta degree from the circular line? Okay, or I can take sinusoidal line also. Means the concept is same. If this is origin, if this is origin, this point is origin, and I have a sinusoidal line. I have a sinusoidal line. If there is sinusoidal line, then every point on this sinusoidal line, this is x-axis. At every x, it will go hit one point in sinusoidal line. There is a direction of sinusoidal line. It is going like this. Direction of sinusoidal line. It is going like this. Can I find another line that same x? If I draw the direction of that line, it will be perpendicular to this line. Make sense? Okay, then what is the algorithm we have used? Algorithm will be same. This is pseudo calculus problem. Means whatever we have solved it for simple case, same algorithm will work in complex case also. Simple case, we have taken that if this is x-axis, and this is a straight line. If this is a straight line, what is the line that is perpendicular to this line? This is simplest case. This line is considered that this line is y equal to x by a square root of 3. y equal to x by square root of 3 means it makes 30 degree from the x axis, whatever it. I have a line with equation is y equal to x by square root of 3 or y by x equal to 1 by square root of 3. What is the equation of line that is perpendicular to this line? Okay, means every moment x axis I go hit here, x axis I go hit here. These are the points I am seeing. These points, if I take line direction, where everywhere line direction is same only, I take another line somewhere, I take another line somewhere, then this line every point, if I take this, if this is flat in x axis, x axis, then x axis, and on x axis if I touch this point here, touch this point here, then this point, whatever direction I am seeing, okay, we can think in this fashion. This is also 90 degree. This is simple. So if from here, if I touch this point, then this point is x comma y. I see direction of x at x point x comma. I believe it makes sense. Consider this is x axis. Okay, and this is a line, and there is another line. At x axis, I take any point x here, go hit here, and x go down and hit here. Okay, now here the point is considered x comma y1, and same here the point is x comma y2. At x comma y1, what is direction of this line? At x comma y2, what is direction of this line? This two direction should be at 90 degree to each other. That is the concept. Okay, if this is x-axis, okay, in that fashion means if I take another x and go hit here and it take hit here, that places also line direction, both line directions should be perpendicular to each other. Then to find the solution, we first represented the line through vector, then found another vector that is perpendicular to it by dot product, and then from that vector we found the line. That is the algorithm we started. So if this is x-axis and this is the line y by x equal to 1 by square root of 3, consider there is any point here. There is any point here, and that point is x comma y. Then this vector representation is xi plus yj. That is xi plus y equal to x by square root of 3j. That is xi plus x by square root of 3 x by square root of 3j. I believe it is all right. I can take out x. Then it is, if I just think about direction, I can take out x. I plus 1 by a square root of 3j. I plus 1 by a square root of 3j is the equation of this vector. Makes sense? I have any point x comma y here. Then xi plus yj, this is origin. So this vector representation is xi plus yj. Y equal to 1 by the square root of 3j. Y equal to x by square root of 3. In that sense, this vector representation will be xi plus x by a square root of 3j. This is a vector representation. I can take out x, then it becomes I plus 1 by a square root of 3j bracket into x. X I can kick out because this is giving me proper vector. This is not a unit vector, but this is a proper vector. I plus 1 by a square root of 3j. This is the equation of this vector. If that is the case, consider there is another line that vector representation is alpha I plus beta j. Just see the procedure. Alpha I plus beta j. Alpha I plus beta j is a unit vector. Means alpha square plus beta square root equal to 1. Dot product of these two vectors will be 0. Alpha I plus beta j dot I plus 1 by a square root of 3j equal to 0. Because angle is 90 degree. In that fashion, it becomes alpha plus beta by a square root of 3 equal to 0. In that way, it becomes beta by a square root of 3 equal to minus alpha. In that way, it becomes beta by alpha equal to minus square root of 3. Beta by alpha equal to minus square root of 3. I believe it is all right. Minus square root of 3. beta by a square root of 3 equal to minus alpha. Beta by alpha equal to minus square root of 3. All right. Okay, beta and alpha are 2 points on the perpendicular line. I can represent it as x and y. So y by x equal to minus square root of 3. Y equal to minus square root of 3x. This is the equation of the line that is perpendicular to this line. Okay, y equal to minus square root of 3x. This is the equation of the line y by x equal to minus square root of 3. Okay, y by x minus square root of 3. Square root of 3 is the for the sine 60 degree. I believe so. Sine 60 degree. That is the square root of 3. Minus square root of 3. Minus square root of 3, if I say, we are trying, this is the 30 degree. Means this is at 60 degree from x-axis. Okay, minus square root of 3 means this line will be at 60 degree from the x-axis downward. This is the perpendicular. That's why it is minus. If it is plus, y equal to square root of 3x, it will be plus 60 degree minus. So it is perpendicular. Let's try to use same algorithm. This is pseudo calculus problem. Whatever the way we have solved our problem through simplest way, same way we will proceed here. Okay, I believe it is all right. Same way we will proceed here. If I proceed in same way, I have now sinusoidal wave. I have a sinusoidal wave. And sinusoidal wave, first I am trying to find perpendicular to the sinusoidal wave. First go is try to find a vector representation of sinusoidal wave. Consider there is any point x comma y on the sinusoidal wave. From origin, if I take a vector, it becomes xi plus yj. This is the vector representation of sinusoidal wave. That is xi plus y equal to sin x. This is sinusoidal wave. Y equal to sin x. X xi plus yj. Xi plus sin x j. This is the equation of the vector where x and sin x both keep varying. Okay, what is the next step? Next step is to take x out. Now it becomes I plus sin x by x j bracket close into x. X I'll kick it out. This is what we did. Now we have I. This is the very peculiar way to solve any problem. Start with a non-calculus way. Start solving anything where calculus is not involved. That is the concept. So now we have I plus sin x by xj. It is the vector representation of a vector that represents a sin x. Y equal to sin x. Y equal to sin x means if this is sinusoidal wave and this is x-axis, everywhere y means height. Everywhere height is sine of x. When x is pi by 2, height is 1. When x is 0, height is 0. When x is pi, height is again 0. Okay, so vector representation is I plus sin x by xj. Okay, now I am trying to find the vector that is perpendicular to it. Up. Sorry, pause here. That is the difference between a straight line and a curved line. In a straight line, we had equation like I plus 1 by a square root of 3j. If someone remembers, I plus actually it was xi plus yj. If I take out x, it's become I plus y by xj bracket close into x. Common thing I can take it out. It becomes I plus y by xj. Y by x was 1 by a square root of 3. That is a constant. It became I plus 1 by a square root of 3j. Here it became I plus sin x by xj. Oh, there is a difference. There it is a numeric number where it is algebra, where numerator algebra and there is a division that is y by x, sin x by x, where the numerator is sin x and that is function over x. The numerator that is function over x Fortunately, x is available in the denominator. Means more or less sin x by x is function over x fx by x. If numerator is a function over denominator, then this is not simple division. Here we have to enter into calculus. We have demonstrated it very well. Like I have a bag of orange and I have a bag of tamarind. One is orange, one is tamarind. In orange bag, in orange bag, I have three oranges. In tamarind bag, I have 12 tamarind. In orange bag, I have 4 oranges. In tamarind bag, I have 16 tamarind. Okay, what is tamarind by orange? Per orange there are 4 tamarind. This is called division. Per orange there are 4 tamarind. If I add one more orange, I have to add 4 tamarind every time because per orange is 4 tamarind. Okay, now when I count in the orange bag, I have 2 oranges, where in tamarind bag I have 4 tamarind. In orange bag, if I count anytime, then there are 3 oranges. In tamarind bag, there are 9 tamarind. In orange bag, I have 4 oranges. There are 16 tamarind in the tamarind bag. How many tamarind per orange? It looks like relationship is square. 4 by 2, then 9 by 3, then 16 by 4. It is square. It comes in algebra. Now, it is not a constant number. 4 by 2 is 2, 9 by 3 is 3, and then 16 by 4 is 4. It is not a constant number. I cannot say that tamarind by orange is 2 because we have seen 3, 4 cases also. I can say if orange is x, then tamarind is x square. This is how it looks like. How many tamarind per orange? Then it is x square by x equal to x. That is not true. Equal to x means if I add one orange in the orange bag, I have to add x tamarind in the tamarind bag, where x is the number of orange at that moment. At that moment. If I have 10 orange in the orange bag, then at that time we have 100 tamarind in the tamarind bag. If I add one orange in the orange bag, at that moment the orange bag has 10 oranges. That is x. Then I have to add x here as per the division x square by x. Now I'll add x here, it will become 100 at 10. Or if I take 11, then it will become 111. Okay, so it becomes here 11 and here 110. It should be 121. So what is the problem here? Problem is that tamarind is x square and orange is x. How many tamarind per orange? X square by x. But x square, that is the count of tamarind, is dependent upon x. X square is function over x. That it can be written as fx by x. The numerator is function over x and x is denominator. If that is the case, then definition what we are keeping, how many tamarind per orange, will rephrase at what is the change in tamarind I see when there is 1 unit change in orange bag. That definition will change now. If in division it is algebra and numerator is dependent upon denominator, numerator is function over denominator, then definition of division, that is how many numerator per denominator will change into how much numerator would change if I make 1 unit change in denominator. This is differentiation. It will come in the arena of differentiation. Now here calculus will enter. X square by x will be rewritten as dx square by dx. D will be added. Now in that fashion it will become 2x. Means any moment if x is orange count, and at that time if I want to add 1, that is 1 unit change I am making. Then the unit change I will see in tamarind bank will be 2x, not x. It is x square by x will not be x. X square by x will become 2x. Differentiation will come into the picture. So I have to add 20, more or less 21 only. So this is called differentiation. Now we will come back to our previous. Now we have a sinusoidal wave and equation is y equal to sin x. Vector representation is xi plus yj. Okay, x if I take it out, the wave will did in the pure pure linear case, then it was I plus y by xj bracket close into x, that I kicked out x. Now it becomes now I plus y by x. Here it becomes I plus sin x by xj, where numerator is dependent upon denominator. It will be written as d sin x by dx, not sin x by x, because the result is not independent to each division, where numerator is dependent upon denominator and their algebra. It will become d sin x by dx. It will become cos xj, I plus cos xj. This is here where we switched from algebra to calculus. Now, our vector representation of sinusoidal wave is not xi plus sin xj. This is the first vector representation we did. Xi plus sin xj. Then in shortcut we wrote I plus sin x by xj into x I kicked out. Okay, the vector representation of sinusoidal wave is I plus cos xj. Okay, I don't want to keep out x. Why you kicked out x? Keep it. I'm not saying that you kick it out. But then it will become I plus cos xj bracket close into x. Now this part is dependent upon x. This is multiplication. X outside we kicked out, it will become dx. The full representation as a vector of sinusoidal wave is I plus cos xj bracket close into dx. Makes sense? Anyway, I can kick out dx now because we want to retain the vector only, not the full I want, because I'm interested in direction now. So sinusoidal wave, if I see, then vector representation is I plus cos xj. What is the vector that is perpendicular to it? That is alpha I plus beta j, which is a unit vector. Then alpha square plus beta square equal to 1, or alpha square plus beta square root equal to 1, being alpha I plus beta j is a unit vector that is perpendicular to the sinusoidal line. I believe it is all right. Okay, in that fashion, the way we did, in that fashion, it will become alpha plus beta cos x equal to 0 dot product alpha I plus beta j dot product with I plus cos x j equal to 0, because they are at 90 degree. Alpha plus beta cos x equal to 0. In that way, beta cos x equal to minus alpha. Beta by alpha equal to minus sec x. Beta by alpha equal to minus 1 by cos x. Okay, I believe it is all right. Beta, if I replace with y and alpha with x, because they represent y and x only, then it becomes y by x equal to minus 1 by cos x. It becomes it becomes y by x equal to minus 1 by cos x. Now again, y and x is all right, but right side is not constant. It should be constant. If it is constant, then this is the equation of the line, y equal to minus 1 by cos x into x. That is the equation of the line, but y by x is not constant. It is a variable. If it is a variable, or if I write what is the formula of a line, y equal to minus 1 by cos x, y equal to minus 1 by cos x into x. Now x cos x, y. Okay, x and cos x, that is on right side. Now someone would say that it looks like x by cos x, something similar to something similar, where we have a kind of division that turned into differentiation. Means dependency and independency looks like. So better we will solve it here only. Y by x equal to minus 1 by cos x. Y by x is not constant, it should be constant, but it is a function over x. Okay, in that fashion, we have to change dy by dx, y and by x into dy by dx. What will happen if consider that this cos x, all these are non-calculus. By mistake, if I convert y by x into differential dy by dx, and unfortunately it was not a calculus problem, then no problem. Differentiation is subset of differential equation. Different of I'm sorry, division is subset of differentiation. and multiplication or addition is subset of integral calculus. Any multiplication I can transform into integral calculus, no problem. Result will be same. Any division I can transform into differentiation, no problem. Okay, like if I have a division that is y, the division is y 5 by 2. Division is 5 by 2. I can write a d5 by d2 or something like that. Means there is no problem. Okay, result will be same. Or integration is 5 into 2. I'm sorry, I think we can better do it in other way. 5 into x. This is the 5 into x, where y into x is the normal integration. Y into x is the normal multiplication, where y is function of x will convert it into integration. Y into dx, where y is function over x. But it is 5 into x, 5 is constant. Still I can write as 5 dx. And x 5 into x dx. If x was 2 earlier, consider 5 into 2. Rather than 5 into 2, I wrote it as 5 into x. That is same thing because 1 is constant. Now I can rewrite it as 5 into dx. Limit is 2 is there, so 2 will be replaced by 0 to 2. 5 dx 0 to 2. Dx integration is x 0 to 2. It will come as 5 into 2 only. The differentiation will work in similar fashion. So any division I can reconvert into differentiation, no problem. So y by x I converted into dy by dx equal to minus 1 by cos x. Now it becomes dy equal to minus 1 by cos x dx, or dy equal to minus dx by cos x. Okay, dy integration is y. All right. Whatever the integration comes as dx by d minus dx by cos x, whatever, or minus sec x dx. Okay, I really don't know what is the integration of sec x. Okay, whatever it comes, then dx will go away. I won't put limit there. Dx will go away and it will come in x only, function of x only. Y equality function in x, that is the line that is perpendicular to the sinusoidal line, and it is not cos x. Generally people think that cos x is at perpendicular to the sin x. That is not true. That is not true because when sine is 0, when x is 0, at that moment the sinusoidal line is moving like this. If someone sees sinusoidal line is moving like this at this moment when sine is x is 0. Now we had a vector of sinusoidal is I plus cos xj. At x equal to 0, it is I plus j. Whereas if I take cosine curve when x is 0, when x is, what is the vector representation of cosine curve? Leave the vector representation. Cosine curve will be, if this is x axis and y axis, then cosine curve will be 1 at x equal to 0, and it will be a flat line. There the vector representation will be I, means it will be a exactly flat line, because dy by dx if I take when x equal to 0, y equal to cos x, dy by dx is sin x, x equal to 0, there dy by dx is 0, means it will be a completely a flat line. I can say I. So I, when x equal to 0 for the line cos x, I dot I plus j is not 0. Cos x is not perpendicular line to the sin x. That is minus integration of sec x dx. That line is perpendicular to the sin x. Anyway, we will talk more on it. We are making repeated here and there so that it will stick to people's mind that how to move up in mathematics, how from simple we catch the calculus, how we transform our simple problem into a calculus from. Anyway, please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.